Okay. So, in the previous lecture, we are considering shifting to the right, shifting to the left. If the sequence is actually a real time sequence, that is obtained by sampling an analog signal, and therefore, this is the 0th sampling point, this is the first sampling point, this is second sampling point, then this shifting actually amounts to delaying of the signal, because delaying or advancing, because suppose this is your analog signal, you obtained A, you obtained B, you obtained C, dot 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 dot, okay, A prime, you obtain them. So, you got a sequence A prime, A, B, C, like that. Okay. And if it is actually time, if I do not write as an index, so this is at 0, this is at t, this is at 2t, this is at minus t, like that. Now, if I shift it to the right by 1, say, so A will go here, okay, A will go here, A prime will come here, B will go here, C will go here. So, this is t, A will come to t, B will come to 2t, C will come. So, this sequence actually, if it is plotted as a function of time, this is delayed, because C was coming at 2t, now it is coming at 3t, B was coming at t, it is now coming at 2t, A was coming at 0, now it is coming at t, A prime was coming at minus t, it is coming at A prime at 0. So, it is shifted, it is delayed by an amount capital T. So, shifting the sequence by 1 point means this time signal, if you make it as a function of time, this is delayed by 1 sampling point. Okay. And therefore, if you shift that original sequence by k indices like y n minus k, it will amount to delaying it by k times t. Okay. That is, from 0, A will move to k t, from capital T, B will move to k plus 1 t, from 2 t, C will move to k plus 2 t. Okay. So, k times the sampling period, that many clock, it will be delayed. Okay. So, if it is a pure time signal, shifting in sequence actually means in time domain the sequence is, or the signal is delayed, or if it is shifted to the left, that means I am moving it back. So, it is advanced in time. So, either delayed in time or advancement in time, but that is when the sequence is actually obtained from a temporal sequence, that is a function of time, a sequence where actually this axis corresponds to time. The sampling points are nothing but, actually this index points are nothing but sampling points. So, 0, 1 means 1 into t, 2 means 2 into t, 3 means 3 into t. So, you can plot it as a function of t. This is obtained possibly by sampling this, okay, like this was the envelope, I was sampling this, now the envelope is shifting. So, analog function is delayed by capital T, and then if I sample, this A prime does not occur here, it occurs here, A does not occur here, A occurs here. The analog signal is delayed by capital T times. So, actually it amounts to delaying time for the analog signal or for that sample train as a function of time, when plotted as a function of time, it gets delayed by capital T for every shift. All right. Having said this, there are some important sequences, basic sequences which you should know. One is called delta n. Now, this delta has nothing to do with Dirac delta function in analog signal processing. We borrow the same symbol, but its definition is purely on its own here. It means it is a sequence which has exact value equal to 1, that is value equal to 1 at n equal to 0, otherwise it has all 0 values everywhere. So, delta n is equal to 1 for n equal to 0 and equal to 0 otherwise. All right. There is another sequence u n, it means it is a unit step sequence. This is called unit sample sequence, not unit impulse. we call it unit sample sequence. But I tell you one thing, because we have been using this delta function or impulse unit impulse function in analog so often with this symbol delta, sometimes we also call it unit impulse sequence by mistake, but that mistake is well accepted. There is nothing impulsive about it. Even if we say unit impulse sequence, it basically means unit sample sequence, its value is 1. Okay, it has got nothing to do with actual impulse function, that is delta function. If I ever call it impulse sequence, unit impulse sequence, basically that is a mistake, that though acceptable mistake, and that actually would mean this. This is not that original impulse function, that is Dirac delta function. Okay, this is a word of caution. UN is called unit step sequence. One, all values 1 on this side, 0 on this side. So, UN is equal to 1 for n 0, 1, 2 dot 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 and 0 otherwise. Then if I ask you, can I write UN in terms of delta n, and can I write delta n in terms of UN? Now, you see UN you can view as though there is one impulse and 0, 0, 0 everywhere, delta n. Then another one, if I take delta n minus 1, it will be shifted. So, this fellow will come here and then zeros, zeros, zeros as before. If I add these two, I will get 1 coming here, 1 plus 0. So, 1, 1 plus 0, 1, and all other points 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0. Okay, so, I will get 1 and 1, this part will come, other parts will be 0. But if I have another say delta say minus 2, n minus 2. So, delta n means this 1 will be shifted to location 2 and 0 here, because this 0 will move here, this 0 will move here, this 0 will move here. So, all other points are zeros. If I add the 3, 1 plus 0 plus 0, 1, 0 plus 1 plus 0, 1, 0 plus 0 plus 1, 1. All other points will be zeros, because 0 plus 0 plus 0, 0 plus 0 plus 0. But this way, if I go on adding delta n plus delta n minus 1 plus delta n minus 2 plus dot 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 dot, then I get back UN. So, UN easily you can see delta n, then delta n minus 1, then delta n minus 2 dot 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 dot. So, compactly you can write R 0 to infinity delta n minus R. So, R equal to 0 means delta n, R equal to 1 means delta n minus 1, delta n minus 2 dot 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 dot. So, this is how you write UN in terms of delta n, and delta n can be written in terms of UN in this way. This is your UN. Okay. And what is UN minus 1? This is nothing but this sequence will be shifted to the right by 1. So, earlier this 1 was occurring at 0, this will occur at 1. Next one was occurring at 1, this will occur at 2. This 0 was occurring at minus 1, this will move here. So, this will be 0. Then all others are zeros, and the 1s will continue. Then if I subtract UN minus 1 from UN, what will I get? If I subtract UN minus 1 from UN, these 2 will cancel, these 2 will cancel, these 2 will cancel, they will all cancel, only this 1 minus 0 that will remain. This side is 0 minus 0, 0 minus 0, so all zeros. So, what will happen is, you will get a 1 here, 1 and then 0, 0, 0, 0, 0, 0, 0, 0, 0, but this is delta n. That means, delta n is UN okay. One more interesting thing, in analog, so you take cosine capital omega t. Remember, in analog frequency we denote by the frequency as radian per second. radian per second we denote by capital omega. So, radian per second into time second. So, second cancels because this whole argument has to be an angle. So, radian per second into second, it becomes radian. So, cos of radian. So, this is analog frequency, but for any capital omega we know this will be periodic over a period 2 pi by capital omega. This is because if instead of time t you go further up by this amount 2 pi by omega, this omega cancels. So, you get basically cosine omega t plus 2 pi, omega cancels, which is cosine omega t. So, it is periodic for any capital omega, this periodic over this period. Okay. For any, so period is this, if it analog frequency is capital omega radian per second, then we know it has to be a periodic function, we know how it looks like sinusoidal waveform, okay, and period is this. But if we construct in an analogous manner some small omega n instead of capital omega, in digital case we use small omega, and remember again this has to be radian, but there is no time involved in n, it is dimensionless. Therefore, small omega must be just radian, not radian per second, because there is no second involved in n is just a dimensionless integer. So, small omega is called digital frequency, its unit is radian, but you will see that this is not necessarily periodic for any small omega. Why? Because suppose it is periodic for any small omega over a period capital N. So, whatever I observe at small n plus capital N also, you should observe the same thing, it should be equal if it is periodic. That means, cosine, this is right, omega small n plus omega capital N. So, this is possible only if this is either 2 pi or 4 pi or 6 pi, like that. There is 2 k pi where k can be 1, 2 dot 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 dot, which means omega is 2 k pi by n. So, not for any arbitrary omega this relation will be valid. This will be valid, that is will be periodic over a period capital N for specific choice of omega. That is 2 k times pi, k can be 1, 2, 3 anything, divided by capital N. For those specific discrete omegas only, this will be periodic. But in the case of analog, it is periodic for any capital omega. This is a very big difference. Okay? Now, I consider a general sequence x n. I consider a general sequence x n. Say x of n, it is x 0 at 0th point, it is x 1 at point number 1, x 2 at point number 2 dot 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 dot, maybe it is x minus 1 at point minus 1 dot 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 dot. Now, this I can write in this way, is a summation of again various sub sequences, say 1 which is x 0 here, but 0 everywhere. Then another one which is x 1 here, but 0 everywhere. Then another one x 2 here, but 0 everywhere else. Another one, if you go to the minus side, x minus 1, this value at minus 1, but 0 everywhere else, like this. If I add all of them, x 0 plus 0 plus 0 plus 0 plus 0, you get x 0, x 0 plus x 1 plus 0 plus 0 plus 0, you get x 1, 0 plus 0 plus x 2 plus 0 plus dot 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 dot, you get x 2, 0 plus 0 plus 0 plus x minus 1 plus 0, 0, you get x minus 1. So, by adding them, that is superimposing them, you get back your original sequence. But what is this? This is nothing but x 0 times delta n. Why? Because You remember what was delta n? What was delta n? This is delta n. 1 here at 0th point, 0 everywhere. So, what is some constant x 0 times delta n? So, this 1 will be multiplied by x 0. So, height will be x 0, zeros will be multiplied by x 0, but that value will be 0. So, it will be x 0 and all zeros. Next, this will be x 1 into delta n minus 1. What is delta n minus 1? This sequence will be shifted to the right by 1. This 1 will move here and this will become 0, this is 0, this. If you multiply this by x 1, so this height will become x 1, all other zeros will remain 0. So, it will become x 1 0. Then by the same logic, it will be x 2 delta n minus 2. It will be x minus 1. Now, this is shifted to the left. So, n plus 1. If delta is n plus 1, this will be shifted to the left, 1 will move here, okay, at 0 0 0, that will be delta n plus 1. And that if you multiply by x minus 1, this height will be x minus 1, others will remain 0, you get this. So, if you add them, you get x n, which means x n is a summation of some subsequences. One subsequence, another subsequence. So, various subsequences are superimposed on each other and you get your x n. So, you can write like this, x minus 1 dot 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 x minus 1 delta n plus 1 from here, then x 0 delta n, then x 1 delta n minus 1, x 2 delta n minus 2 and dot 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 dot. This entire thing you can write in a compact form like this. You start with x r and delta n minus r, and r will be from minus infinity to infinity. Just see, if r equal to 0, x of 0 delta n minus 1, you have got x of 0, sorry, x of 0 delta n minus 0, if r is 0. So, x 0 delta n, so x 0 delta n. If r is 1, x 1 delta n minus 1, x 1 delta n minus 1. R is 2, x 2 delta n minus 2, x 2 delta n minus 2, so on and so forth. On the other hand, if r is minus 1, x minus 1 delta n plus 1, x minus 1 delta n plus 1, and so on the back. Okay, this is a very important result. This will be using. So, any sequence, it means is a sum of various subsequences. All right, this is very important. Now, we will be considering processing of sequences. Okay. That is, there is one system, what inside is there, what there is there inside, I do not know, I do not care, but it takes one sequence, maybe x n as input, does something on it, it gives you an output y n. All right, it gives you an output y n. Now, this system will be called linear system if it follows superposition principle. Means, suppose I give this system, I denote by an operator t. This is not time, this is an operator t. That is y n I write as t working on an input x n. So, system y n is t working on x n. Now, is it, if it is linear, superposition will be valid. That is, suppose I give one input x 1 n and output is y 1 n, which is nothing but t working on x 1 n. Fine. Suppose I give another input x 2 n and find out the output, and I call it y 2 n, which is nothing but t x 2 n. In that case, now, if I make one linear combination, some constant time c 1 x 1 n, means every sample multiplied by some constant C1 as I told you, and C2 x2n, that is every sample here multiplied by C2, and then the two sequences are added. This I give to the input. So, T of that, there is a new input obtained by combining them. C1 x1n one sequence, C2 x2n another sequence added. This is a total sequence which I give at the input, a linear combination of two. Then output yn should be, if it is linear, should be C1 should go out, T should work on this only. Again C2 should go out, T should work on this only, and these two components will get added because this was added. If this is true, it is linear, otherwise not. It means total output will be, total output of the system will be response summation of response due to this component and response due to this component, that is this part and this part. And response due to this component means response due to this basic component x1n multiplied by the constant C1. This T, that is first you multiplied by C1 and then process through T, you obtain the same thing, you first process by T and then again multiply by the same number. Okay. That should be valid, and individual responses, that is response due to this part here, response due to this part here, they should get added. If this is true, it is linear, otherwise not. This is called principle of superposition. Very interestingly, an equation like this, y equal to mx, if x is an input to a system, forget about sequence, there is no sequence. X is one variable which is input to a system, output is y, and output and input is related like this. Suppose there is a system, there is no sequence, it is just a variable x, output is variable y, and they are related by mx. Then it is linear, because if you give x1, output is y1, say m x1. If you give x2, output is m x2. If you give C1 x1 plus C2 x2, output will be m times this, which you can write as C1 into m x1, but m x1 is y1 plus C2 into m x2 is y2. Okay. So, this is satisfying superposition principle. So, y equal to mx is linear, but if I give you y equal to mx plus c, then it is not linear, though the plot will be a straight line, but technically it is not linear, it is called actually affine. It is not linear, because suppose x1 you get mx1 plus c, you give x2 mx2 plus c. If I give just a combination, say x1, c1 is 1, okay, this is my y1, this is my y2. So, x1 gives rise to y1, x2 gives rise to y2. So, if I give x1 plus x2, output should be y1 plus y2 if linear. But now output will be m into, this is my x now. So, x1 plus x2 plus c. Okay, m into input is x1 plus x2, so x1 plus x2, m into that plus c. But this is mx1 plus mx2 plus c. This is not same as y1 plus y2, because if you have y1 plus y2, you have mx1, mx2. So, mx1, mx2 present, but you have got 2 c, here you have got only 1 c. So, it is not strictly linear. Okay, this is very interesting. So, with this for linearity, and there is another thing called shift invariant, which comes from time invariance, that is, suppose you are giving x n, there is a y n. Okay. Now, say x n, as a matter of fact, suppose x n is obtained by indeed sampling some analog signal. So, these are this sampling, this index points 1, 2, 3, they actually correspond to sampling point. This corresponds to capital T, this is 2T, this is 3T, like that. As a, we are taking for example, suppose it is like this. So, actually I am writing as a function, as a sequence. So, this is 0, 1, 2, like that, but it is actually a time sequence. So, it will be in terms of time, it is 0, capital T, 2T, 3T, like that. And this sequence is given here, you are getting an output. Now, suppose that original time sequence is delayed. Original time sequence is delayed. That means, this will be shifted. Suppose it is shifted by some amount, say m. That means, this guy x 0 will come to m, x 1 will come to m plus 1, okay, and like that. X 3, sorry, x 2 will come to m plus 2 dot 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 dot. Assume that this left side was 0. I started from this index. So, that means, this is delayed by this in terms of actual time. This is delayed by m into t, that much of time, where t is every sampling period. If I give this to the input now, what will happen? If the system is such, its property does not change, then what will happen? Instead of giving the input this sequence now, if I delay it by some amount, new output will be nothing but of the same type as y n, because system's property has not changed, but that output will be placed here. Okay, whatever earlier was getting y 0, now y 0 will also occur here, y 1 will occur here, y 2 will occur here. So, output also gets delayed. Our earlier output maybe was like this, y 0, y 1, y 2, like that. Earlier when I gave this, I got that. If I shift it, that means actual time signal is delayed by mt. These outputs, if the system does not change the property, okay, it remains invariant, then delayed input, so what? If it has come now, my processing will remain same. So, I will get the same similar output, only it will be located from here onwards. So, output also will get shifted. This waveform will just get shifted by the same amount m. So, that means, if input is shifted by any amount m, output also should be shifted by any amount of m, if the system property does not change with time. If this happens, then it is called time invariant or shift invariant. That is, if x n gives rise to y n as t of x n, and suppose I give a delayed sequence n minus m, it is a delayed sequence, you can call it new sequence g n, which is nothing but delayed version of this. Then new output maybe y 1 n, which is t working on this g n, will be same as previous output, but that was also delayed by the same amount. That is, I give x n, got y n. X n I now delay, shift, and this can be positive, negative both. So, if it is shifted, it is a shifted version, I give it a new name g n. That I give here, like this I gave here. Corresponding output y 1 n. That will be, that is t working on g n. That is, if it is g n here, t working on g n, that is the new output y 1 n. That should be nothing but old output only, but delayed by the same amount. If input is delayed by m, input is delayed by m. So, here input shifted here, output also shifted by the same amount m. If this happens, then I say the system is shift invariant. If it is coming from a time signal, I also call it time invariant. Okay. So, I am stopping now. From this, we will now build on systems, linear and shift invariant systems, and calculate the output in terms of input. Thank you very much.